you. Thank you. So I'm excited to host this very last session, saving the best for last, and kudos to all of you for hanging in there. We'll try to make this as interactive as possible. We have a couple of samples also to pass around to really make this real. Changing the fashion industry through new materials. I'd like to get a bit of a gauge of who is in the room. Do we have folks working in the fashion industry? Great. 3. All right. Who is working in material innovation? Nobody. So there's probably quite some, oh, one person, okay. So I bank on you also to actively participate. But it's great because then there's a lot from our side to share with you. Today we're trying to bring those worlds of fashion and innovation, material innovation together. It's a little bit like Mars and Venus. It's not so easy to bring those worlds together. So that's what we're going to dive into, Alissa and I. And as there's so many folks in the room here that are not deeply ingrained in the fashion industry, I'd like to maybe give a bit of context of what we are actually trying to change in this industry. What's the problem that we're trying to tackle? In essence, there's 3 things. First of all, it's a huge industry that uses a large amount of non-renewable resources, really, to produce those clothes. It's the first thing. Secondly, those clothes are, in most of the times, only used for a very, very short period. And that period is getting shorter and shorter over the years. And then thirdly, the majority of all this material ends up in landfill, or it's being incinerated. There's only 1% of all of that waste that is circled into new fibers. So huge impact in waste, water, and carbon. And we're trying to address this through bringing this linear industry, take, make, waste, into something that is circular. And for that, we need innovation, and that's also where Fashion for Good, the organization that I work with, is coming into mix. We're trying to find the most promising innovations from around the world, connect them with industry, bring investors into the mix, and really help those innovations scale. And one of those really promising disruptive innovations is Kintra Fibers. I'm excited that Alissa is with me here today. Alissa is the co-founder and COO of Kintra. And with that, I'd like to really open up the floor and hear from you first, a little bit about you and the journey that brought you to Kintra, how it all came about.
Sure. Thank you. I'm very excited to be here today. So Kintra came about, I had started a backpack line. I was a designer, and business was good. It was growing. I was honored on the Forbes 30 Under 30 list. I was looking at expanding into new product categories, and then I attended a climate conference, and everything changed for me and for my design approach. I learned that 70% of the impact in the fashion industry comes from the raw materials that we use and the processing of them. And once you learn a statistic like that, you can't unlearn it. The backpack line that I was making was giving back to girls' education across rural, low-income countries. And these are the very communities of girls that are often the most impacted by our changing climate. And here I was, using fossil fuel-based and non-biodegradable synthetics. Those show up in your closet as polyester and nylon. And learning about this, once you take a step back and you look at the system as a whole, I no longer wanted to participate in that system as a designer. I no longer wanted to grow my business relying on fossil fuel-based synthetics while trying to empower these very communities of girls, as I mentioned, that are often the most impacted by our changing climate. And so I started a journey to look for better materials, and I couldn't find any. I couldn't find a material that had the physical performance properties that I needed as a designer that actually met every single planetary criteria that I had learned about and was looking for, and that at least eventually could offer me a price point that I could understand from a design and business perspective. So in my search, instead of finding a new material, I found a co-founder. My co-founder, Billy, is a nanoengineer and also a surfer. And his journey to Kintra was, he loves being out in nature. And often our exploration in nature is enabled by these synthetic, high-performing materials. but these are the very materials that are polluting our beautiful natural environments. So Billy applied his nanoengineering, his material science knowledge, to create a material that had this awesome performance and yet could not pollute the beautiful natural environments that it gets out into. And the result is, of course, Kintra, a material that's 100% bio-based, biodegradable, and made on the exact same industry infrastructure that is used to create traditional polyester.
So that is Kintra, and you're focusing on a solution that addresses polyester. Maybe we'll get a bit of an understanding of what you all know. Textile industry. A couple of fibers are pretty common. There is polyester, there is cotton, there is man-made cellulosic, so viscose, and then there is other natural fibers and animal-based fibers. What does the room here think is the percentage of polyester in total fiber production? Any guesses? 70, I hear here. 80? Ah, you're pretty aggressive. It's 50%, still enormous. And the second most material is then cotton, around 20%. So 50% is polyester, and that is coming from oil, non-renewable resources. And that's what the industry is looking for, replacement for polyester, and that could be on the one side through chemical recycling, using old clothes and reusing them again, so not using PET bottles, which is the most common recycled polyester that you currently see. And another source is then biosynthetics, and that is what Kintra is trying to tackle. So can you explain a little bit in more detail, Alissa, how the technology of Kintra works?
Absolutely. So exactly, and that was a great explanation. So Kintra is a biosynthetic material. So the bio part of that means that it comes from plants instead of fossil fuels. We work with partners that create chemistries from a glucose source. And any type of feedstock, any type of plant can be used. Today we use corn, but it could be the leftover after a harvest. We could use that second generation, that waste stream feedstock, or something even more interesting, an algae could be used. We just need a reliable source of glucose, or I should say our partners. That is then, through a fermentation, yields an input, a molecular building block, or a chemistry, which we put through a synthesis, a synthetic chemistry process, which yields this, our resin. This is exactly how traditional polyester, PET, would look before it is transformed into yarn. And this is our output. And it's not only special because it is 100% bio-based, but this is also inherently biodegradable, specifically in oxygen-rich environments. For example, the oxygen-rich environment of a wastewater treatment facility or the oxygen-rich environment of soil. The reason for that is by designing a material to align with nature, to be able to completely biodegrade in a natural environment, we are having a very good chance of solving the microfiber pollution issue. Every time you wash traditional polyester or nylon, traditional synthetics, millions of tiny plastic particles are released through the laundry, and they end up out in our environment. And these microfibers, these tiny fibrous pieces of plastic, are especially kind of scary because out in the environment, they soak in toxic chemistries like motor oil, pesticides, and they travel up the food chain. They've been found in our bloodstream, and something that is top of mind for me right now, for maybe obvious reasons, is that they've been found in a woman's placenta, potentially affecting our unborn babies. We haven't yet measured all of the human health impacts of these, but we do know that these chemistries are not ones that we want to have in our systems, whether it's our natural, beautiful environment or our own health and safety, our own health systems. So we are designing a material that can completely biodegrade in nature. And the next step, so I mentioned that the reason this is special is it's bio-based and inherently biodegradable. What maybe is designed to not be special about it is that equipment that we use. The same exact equipment that is used to make traditional polyester in this form, we use that, complete drop-in. And in order to transform that into the yarn, ready-to-go yarn, this is Kintra yarn, we use the exact same fiber extrusion or melt spinning equipment. So the process for that is this is put through what looks like a spaghetti making machine or a shower head, and the result is a ready-to-go yarn. That is then, of course, either knit or woven into a textile. And we can pass these around if you want to take a look and kind of see a sneak peek of maybe what's to come in the fashion industry. These are, of course, undyed. We are dyeing, excuse me, we are starting to dye our materials. And we have quite a wide variety of materials that you can kind of see. Everything from what would be suitable for a technical outerwear jacket to a beautiful silk-like material to footwear to something that's just very soft and comfy and cozy and casual.
Yeah, we can also pass it around.
Pass it all around.
You have a sip here and pass this around.
Excuse me.
To make this a real interactive session. So have a sip. So it sounds a little bit like you're addressing this holy grail, right? It uses plant-based input, renewable inputs. The process saves wastewater carbon. It can eventually cycle back into new garments, fully recyclable, fully compostable as an alternative stream. How can it all be true?
That's right, and that's by design. You know, because the problem today is that these most commonly used fibers are not designed to align with nature, but yet they're so versatile. You can literally design them from the molecule forward. We have full control over the outcome, the output of our material from a performance standpoint. So that's where you get this beautiful versatility. And I didn't mention, but compared to traditional polyester, our material is just as strong, but it's 10 times softer, and we have an inherent stretch recovery of about 10 to 15% that traditional polyester does not have. So it's a very unique performance that a lot of designers, like myself, look for in a material. And in terms of the nature piece, that's by design. For us, being nature aligned and that biodegradability, that's a non-negotiable. Microfiber pollution is uncontrollable. People are working on, you know, washing machine filters and others, but if we can control it from smart materials design, that's the future. And the infrastructure today is not there to compost textiles that you're, you know, touching, feeling, we're passing around right now. But I do believe in a future where we can change infrastructure. We can create, you know, if we have compostable textiles, why not cycle them back to our earth? And then that, you know, starts the cycle again. More perhaps topically and currently, there are incredible innovators working on chemical recycling, or molecular recycling, I should say. Because Kintra is in the category of polyester, it is a new material that we've created in the category of polyester. It is not PET. We can also, just like we can bring those molecules together in that same reactor system, we can also take them apart in the same reactor systems that are being developed for chemical recycling. So there's a number of ways that we can keep this in circularity.
So you're part also of a multi-stakeholder pilot with some of the Fashion for Good partners. Bestseller is one of them, Inditex, Reformation. What's the aim of that pilot? What do you try to achieve?
Yeah, so we love being a part of the Fashion for Good network. And through Fashion for Good, we have an opportunity to work with some of the world's most innovative brands. And together with these brands, they help guide our design direction, because I mentioned, you know, there's a lot of versatility we can do. So where do we start? What do the brands really want? And with our Fashion for Good partners, what we see is that they really look at their supply chain. They look at their hotspots of what do they want to address? What is their most commonly used category that they can alter, that they can shift, that they can introduce to their consumers? And we learn the specs of the fabrics that they're using. We learn about the yarns. We connect with their suppliers, and we recreate it using Kintra. And all those samples that you're having an opportunity to check out today, those were created in part with some of our Fashion for Good partners.
And the material that you're trying to replace, also looking at those samples, what are your hypotheses?
Yes, that's a great question.
So discuss it with the partners. What do they try to replace?
Yes. So, you know, we often get, you know, immediately, because it is a synthetic material, we're often immediately just put into the category of polyester. I mean, technically our material is in the category of a polyester type of material. But once the brand partners have an opportunity to touch, feel the samples, it opens up new and different categories that we can explore. Some brands are very excited to use Kintra to help support their man-made cellulosic programs, because they have some challenges sourcing certain types of cellulosic fibers that they're looking for. Other brands look at us and they're like, oh wow, this is almost exactly like the nylon that we're currently using. So it really is, I can't stress enough, we've created an entirely new material. It's like giving an artist, a new color that they've never had access to before. It unlocks these new and different performance properties, so it can really be used across a variety of different categories of fiber.
Okay, cool. Tell us in which stage you are. You were founded in 2018,
yes,
if I'm not mistaken. How far along are you on this journey to scaling and really building the company?
So last year, we closed our Series A, which was led by H&M, and had participation from Fashion for Good and Bestseller as well. And we are scaling. So our big focus for the year is, right now we're at pilot scale. For some context, for pilot scale, that means we're producing anywhere from about 50 kilograms to 100 kilograms at a time per batch. We will soon be moving to tons, from kilograms to tons, and moving from pilot to demonstration quantities, and continuing to scale up and grow our production. In addition to the partners that we spoke about today, we're onboarding new partners this year, which we're really excited about, including some manufacturing partners that will support all the different brands that we're working with.
Yeah, that is great. Because eventually the brands are fabulous to signal demand, but you need the whole supply chain, all the expertise that sits also in Asia, in the production countries, to get really incentivized, empowered, and then drive this into the big machine. I think that's what we would love to see eventually, to move from pilot to this widespread scaling and adoption.
Absolutely.
Well, we have more questions here that I could dive in, but I'd love to also engage you guys here a little bit and wonder whether you have some questions to Alissa or to me, so that we can make this a bit more interactive. Here we have somebody. Would you like to say your name?
Hi, I'm Eva, and I would like to know what designers and what brands are already working with you.
Yeah, great question. So we are piloting, publicly announced. It has been H&M, Bestseller, Intedex, which is the parent company of Zara, you may know, and many other brands, and Reformation. Behind the scenes, we're working with a number of wonderful brands, from everything across, everyday accessible apparel to ready-to-wear, mid-designer to very high-end luxury behind the scenes.
Here? Oh.
Oh, I'm Birgit. One question concerning the price difference. As polyester is known as quite cheap material, is this a disadvantage in your business plans, or what's the price difference?
I'm so happy you asked. It's actually one of our competitive advantages. So because we fit that same infrastructure at every single key part of production, right now we are, as I mentioned, we're making batches at a time, but on a continuous plant level operation, all that equipment works for our material. So the cost driver, polyester, just as you mentioned, is so affordable because it's so efficient to manufacture. So is Kintra. So our cost driver becomes our raw materials. And now we know that our raw materials are very affordable, even especially at mass scale. And in a very kind of maybe future forward, maybe soon on the horizon, relatively soon on the horizon vision, we could operate a Kintra biorefinery where the input is a feedstock that we choose, maybe beyond corn, something that can draw down carbon very efficiently and effectively and incorporate a nature-based solution into our work, and go from feedstock directly to yarn. And that's an extremely efficient process. And the costing at that point just becomes the cost of that feedstock. So we're in position to, at mass scale, directly compete with traditional polyester. And in the near term, every time we scale up production, our pricing continues to get better and better.
Yeah. I think, Birgit, what you pointed out is the most critical question. And I think the really compelling component in the Kintra story is that there is this promise of matching price of this very cheap incumbent polyester. I think the challenging part, and maybe we'll dive into that momentarily, is this scale-up phase. And we see that now with many of the solutions, also in other areas, whether it's chemical recycling, so using waste garments. They all have this promise, but it's quite a journey to scale up. And you need additional financing. You need folks that pay that premium in the interim. Policy, fortunately, is now upping the ante. We see, fortunately, on the European side that a lot of legislation is happening, but this immediate trigger to switch to more expensive material that is unfortunately not yet there. That's why, yeah, I'd love to see this whole transition move much faster, but in the long run, yeah, this promise is there. There was another question over here.
I'm Cornelia, and what you just said, Katrin, is exactly the direction my question goes to. How many years will it take, if you give us a modest estimate, until the 50% of polyester-based fabric will be replaced by the kind of materials you innovated? And if you could make a wish, what is the amount of investment or commitment you would need in the next 3 years to accelerate the journey?
Yeah, those are great questions. So we'll be opening up our Series B next year. So there's, that's to come soon. And we're extremely effective with our use of capital because, again, that infrastructure is there. And we are already working with partners that can support our growth needs and our growth trajectory. So the capital that we'll be raising next year, it'll be, a fraction of what you might have seen in industry and other innovations. And for us, in terms of timeline, I think a big part of that comes down to the brand demand. We have the opportunity to scale up to meet demand or scale down because until we build that 60,000 plus ton capacity manufacturing plant, we can continue making batches of up to 100 tons. And we can do that for our brand partners. So for us, there's this really iterative approach where we don't have to invest in this heavy infrastructure. We can either scale up or scale down to meet the demand of the brands and the manufacturers that we're working with.
And currently, I think biosynthetics or natural bio-based inputs are less than 1%. So it's a very small base that we're starting with. If you look at the 50% polyester share, of that, approximately 15%, actually it dropped 2022 to 2023 by 1%, is recycled PET. So that industry of recycling plastics is maybe 5 years or so ahead of us. Policy has really pushed this, so we hope that we see a similar trajectory if we now look at bio-based biosynthetics or in general just recycled polyester. So I think we have a horizon of 5 years to maybe see a 10% or so uptake eventually. And it will be a mixture, as I said in the beginning. I think it's the biosynthetics, it's recycled, chemical recycled polyesters, also using textiles in the input. But yeah, I think this is fabulous that you all joined us in here. And I have one closing question. And with that, I think this is also a signal for us to wrap it up, right? To
kind of
close this whole stage here. Alissa, if there is one thing that you would like to share with the audience, what they should take away, what would that one single thing be?
Well, to be informed consumers. Often I meet a friend or someone new and they are so excited to tell me about their recycled plastic garment, and I just, I'm like, okay, well, I don't want to, dampen any enthusiasm, but I do want to share about, the problems in recycling plastic bottles to textiles, how that's a one-way ticket to landfill. So now you all know, so share those conversations, have them, but welcome people into the movement, welcome people to explore and try new things and just keep up to date. And just one more is vote. Vote, 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 vote for climate. Vote for climate policy.
And follow Kintra and support Kintra on that journey.
I think, Alissa, you're the perfect example of the abundance of new answers that we saw this DLD. Our minds and horizons have been stretched so far, and I don't know how you feel, but I feel like whatever it is that we need to change, now is the time, because we have the technology, we have the smart scientists and brave thinkers that see the problems and are just like, let's do something else. Thank you so much for joining DLD this year. You have been amazing. Thank you so much, panelists, and see you soon at DLD. Bye-bye.
Thank you to you.
Oh my God.